Hi everyone, Bill Nye here, and today we're diving into the exciting world of gene editing. You know, it's pretty incredible when you think about it. Our bodies are made up of trillions of cells, and each one of those cells contains our entire genetic code. It's like a blueprint, a set of instructions that tells our bodies how to grow, develop, and function. This genetic code is written in a language called DNA, and it determines everything from the color of our eyes to our risk of certain diseases. Now, sometimes there are tiny errors in our DNA, like typos in a book, and these errors can lead to genetic disorders. For a long time, we could only observe these errors, but now, thanks to groundbreaking scientific advancements, we have the power to edit them, to correct those typos. This is where CRISPR comes in, a revolutionary technology that's transforming the field of medicine and beyond. Get ready to have your mind blown, because we're about to explore the incredible potential of gene editing. So what exactly is CRISPR? Well, imagine a pair of tiny molecular scissors that can precisely cut DNA at specific locations. These scissors are actually a protein called Cas9, and it's guided to the right spot on the DNA by a molecule called RNA. This RNA acts like a GPS, leading Cas9 to the exact gene we want to target. Once the DNA is cut, the cell's natural repair mechanisms kick in. Scientists can then take advantage of this repair process to either disrupt a harmful gene or even insert a new healthy gene. The possibilities are truly astonishing. CRISPR is like having a molecular toolkit that allows us to rewrite the code of life itself. With CRISPR, we're standing on the brink of a new era in medicine. We can potentially cure genetic diseases that were once considered untreatable, from sickle cell anemia to cystic fibrosis. And it's not just limited to humans. CRISPR can be used to improve crops, develop new biofuels, and even create disease-resistant livestock. The future is brimming with possibilities, and I can't wait to see how this revolutionary technology continues to shape our world for the better. But now, let's dive into some of the most exciting breakthroughs in CRISPR so far, starting with the groundbreaking approval of Casgevy. And now for a truly remarkable breakthrough in the world of CRISPR, the FDA approval of Casgevy. This is a huge deal, folks, because Casgevy is the very first CRISPR-based gene therapy to receive regulatory approval for treating a genetic disease. It's a momentous occasion that marks a turning point in medical history. Until now, many genetic disorders have been incredibly challenging to treat. We've often been limited to managing symptoms, but Casgevy offers a potential cure. It's designed to tackle sickle cell disease, a debilitating and often life-threatening condition that primarily affects people of African descent. This approval is a testament to the tireless efforts of scientists, researchers, and clinicians who've dedicated their lives to finding better treatments and cures for genetic diseases. It's a shining example of what can be achieved through scientific innovation and collaboration. Sickle cell disease is a painful and often life-limiting condition caused by a single mutation in the gene that produces hemoglobin. Hemoglobin is a protein in red blood cells that carries oxygen throughout the body. In sickle cell disease, this mutation causes red blood cells to become misshapen, like a crescent or sickle, instead of their normal round shape. These sickle-shaped cells can block blood vessels, leading to excruciating pain episodes, organ damage, and a host of other complications. It's a devastating disease that can significantly impact a person's quality of life. Casgevy offers new hope for people living with sickle cell disease. It's a one-time treatment that works by editing the patient's own blood stem cells. These stem cells are like the master cells in our bone marrow that produce all of our blood cells, including red blood cells. Now let's delve into the science behind Casgevy. Here's how it works in a nutshell. First, doctors collect blood stem cells from the patient, then these cells are sent to a lab where they are edited using CRISPR technology. The CRISPR system is programmed to target the faulty gene that causes sickle cell disease. It acts like a pair of molecular scissors, cutting out the mutated section of the gene. Once the faulty gene is removed, the cell's natural repair mechanisms kick in and insert a corrected version of the gene. After the gene editing is complete, the modified stem cells are infused back into the patient. These edited stem cells then go to work producing healthy red blood cells that don't sickle. This can dramatically reduce or even eliminate the symptoms of sickle cell disease, offering patients a chance at a healthier and more fulfilling life. Now, let's shift gears a bit and talk about another blood disorder called beta thalassemia. You might not have heard of it, but it's a big deal, affecting millions of people worldwide. And guess what? CRISPR is showing incredible promise in treating this challenging condition too. See, our red blood cells contain this vital protein called hemoglobin. Hemoglobin's job is to carry oxygen throughout our bodies, kind of like tiny delivery trucks. But with beta thalassemia, the body doesn't produce enough hemoglobin, and that's a problem. People with severe beta thalassemia often rely on regular blood transfusions to survive. Imagine having to go to the hospital every few weeks for a blood transfusion. It's a tough life, but CRISPR offers a beacon of hope for these patients. So, how does CRISPR come into play? Well, scientists have discovered that CRISPR can be used to correct the genetic defects that cause beta thalassemia. It's like having a tiny pair of scissors that can go in and fix the faulty instructions in our DNA. This means that with CRISPR, we have the potential to cure beta thalassemia, freeing patients from the burden of lifelong blood transfusions. It's a game changer, folks. No more needles, no more hospital visits, just the freedom to live a healthy and fulfilling life. Of course, this is cutting-edge science, and it's still early days, but the results so far have been incredibly encouraging. Scientists around the world are working tirelessly to refine these CRISPR-based therapies and make them available to patients as quickly and safely as possible. Now, let's take a closer look at how CRISPR is being used to treat beta thalassemia. One approach involves collecting a patient's own blood stem cells, which are the master cells in our bone marrow that produce all of our blood cells. These stem cells are then sent to a lab, where scientists use CRISPR technology to correct the faulty gene responsible for beta thalassemia. Imagine it like this. CRISPR acts like a spell checker, finding the typos in the genetic code and fixing them with incredible precision. Once the gene editing is complete, the modified stem cells are infused back into the patient. These edited cells then migrate to the bone marrow and start producing healthy red blood cells, restoring the patient's hemoglobin levels to normal. It's like giving the body's blood production system a complete overhaul. The results can be life-changing, freeing patients from the constant need for blood transfusions and allowing them to live healthier, more active lives. But wait, there's more. CRISPR isn't just transforming medicine, it's making waves in other fields too. Remember those molecular scissors we talked about? They're proving to be incredibly versatile, like a Swiss Army knife for gene editing. Scientists are exploring CRISPR's potential to treat a wide range of diseases, from genetic disorders like cystic fibrosis and muscular dystrophy to infectious diseases like HIV and even some types of cancer. It's like having a secret weapon in the fight against some of humanity's toughest challenges. And here's the really exciting part. CRISPR is constantly evolving. Researchers are developing new and improved versions of CRISPR that are even more precise and efficient. It's like upgrading from a pair of rusty scissors to a high-tech laser cutter. Now let's take a field trip to the farm where CRISPR is also plowing new ground. Farmers have always been on the lookout for ways to improve their crops and livestock, and CRISPR is giving them a helping hand. Imagine crops that are more resistant to pests and diseases, reducing the need for harmful pesticides. Picture fruits and vegetables that are more nutritious and stay fresh longer, reducing food waste. CRISPR can make these visions a reality, and it's not just plants that are benefiting from CRISPR. Scientists are exploring ways to use CRISPR to make livestock healthier and more productive. Imagine chickens that are resistant to bird flu or cows that produce more milk. It's all within the realm of possibility. Now, with all this incredible potential comes great responsibility. As we delve deeper into the world of gene editing, it's crucial to consider the ethical implications of this powerful technology. For example, some people worry that CRISPR could be used to create designer babies with specific traits like eye color or intelligence. Others are concerned about the potential for unintended consequences of gene editing, like unforeseen mutations or ecological imbalances. These are complex issues with no easy answers. That's why it's so important to have open and honest conversations about the ethical boundaries of CRISPR. We need to ensure that this technology is used responsibly and for the benefit of all humankind. So there you have it, an overview of the amazing world of CRISPR. From treating genetic diseases to revolutionizing agriculture, CRISPR has the potential to change our world in profound ways. It's like a key that unlocks countless doors to a brighter future. But remember, with great power comes great responsibility. As we continue to explore the vast potential of CRISPR, we must do so with careful consideration of the ethical implications. We need to ensure that this powerful technology is used wisely and for the benefit of all. The future is full of possibilities, and I, for one, am incredibly excited to see what wonders CRISPR will unveil next. It's a time of incredible scientific discovery, and I can't wait to see how this revolutionary technology shapes our world for the better. Well, folks, we've journeyed through the incredible world of CRISPR, and what a journey it's been. From its humble beginnings as a bacterial defense mechanism to its current status as a revolutionary gene editing tool, CRISPR has taken the scientific community by storm. It's like discovering a secret passageway to rewrite the code of life itself, opening up a universe of possibilities for medicine, agriculture, and beyond. Remember those groundbreaking breakthroughs we talked about? The FDA approval of Casgevy for sickle cell disease, the incredible progress in treating beta thalassemia. These are just the tip of the iceberg, folks. CRISPR is like a scientific snowball rolling downhill, gaining momentum and picking up speed with each passing discovery. Imagine a world where genetic diseases are a thing of the past, where children are born free from the burden of inherited conditions. That's the promise of CRISPR, folks, and it's a promise worth striving for. We're talking about potentially curing diseases like cystic fibrosis, Huntington's disease, muscular dystrophy, the list goes on. But it's not just about curing diseases, it's about improving lives. CRISPR has the potential to enhance crop yields, create disease-resistant livestock, and even develop new biofuels. It's about harnessing the power of nature to address some of humanity's most pressing challenges. Now, I know what you're thinking. This all sounds too good to be true. And you're right to be cautious, folks. CRISPR is a powerful tool, and like any tool, it's important to use it responsibly. As we venture further into the frontier of gene editing, we must proceed with caution and engage in thoughtful discussions about the ethical implications. It's like exploring uncharted territory. We need to be mindful of the potential risks and benefits every step of the way. For example, some people worry about the potential for designer babies. Imagine parents being able to choose their child's physical traits, like eye color, height, or even intelligence. Is that something we want? Where do we draw the line? These are complex questions with no easy answers. And what about the potential ecological impact of releasing genetically modified organisms into the environment? We need to carefully consider the potential consequences for biodiversity and the balance of nature. It's our responsibility to ensure that our scientific advancements don't come at the expense of the planet. Despite these challenges, I remain optimistic about the future of CRISPR. It's a technology brimming with potential, and I believe that with careful consideration and responsible use, it can usher in a new era of scientific advancement for the betterment of humankind. Remember, folks, science is a journey, not a destination. There will be bumps along the road, ethical dilemmas to navigate, and unforeseen challenges to overcome. But that's what makes it so exciting. By embracing curiosity, fostering collaboration, and proceeding with a sense of wonder, we can harness the power of CRISPR to create a brighter future for generations to come. And that's our show for today, folks. Remember to stay curious, keep exploring, and never stop questioning the world around you. This is Bill Nye, signing off.